Greetings and welcome to a class in quantitative methods. In the previous session, we discussed the ways of displaying quantitative data by tabular and graphical means. In this session, we want to represent numerical data by a single point. Let's take an example and let's compute all the measures of dispersion. The data set I'm taking is the data set we used earlier, represented by X. If you recall, there were 6 points, and these are given, 1, 2, 3, 4, 5, 6 points, -2, -2, -1, 0, 1, and 5. I now want to compute the measures of dispersion. I start off with the variance. To compute the variance, remember, I need to take the squared deviations from the sample mean. So what I do is, I know that the mean is 0.17. If you remember, it was 1 divided by 6, right? So 0.17. So what I first do is, I look at X minus the mean. So X minus mean is -2 minus 0.17, which is minus 2.17. Similarly, I've got minus 2.17 here. Minus 1 minus 0.17 is minus 1.17. 0 minus 0.17 is minus 0.17. 1 minus 0.17 is 0.83. And 5 minus 0.17 is 4.83. And I add them all up and I should get 0, which is what I get. And the point is that always, right, the mean, is in the middle. So therefore, the middle of the sense of the weights. So therefore, the deviations from the mean must add up to 0. And that's what I get here, 0. But I don't want to compute the variance. I need to take the squared deviations. And therefore, this 2.17 squared is 4.69. Similarly, the second one is also 4.69. 1.17 squared is 1.36. And minus 0.17 squared is 0.03. 0.83 squared is 0.69. And 4.83 squared is 23.36. I add them all up. I get 34.83. And remember now, to compute the variance, I must divide by the sample size minus 1. There are 6 elements out here. I must divide this by 5. So 34.83 divided by 5, I get it as 6.97. And that's what I get here. The variance is 6.97. To compute the standard deviation, I take the square root of 6.97, square root of 6.97, and I get the standard deviation as 2.64. So I've got it here. I've got the variance 6.97 also copied here. Let's go back to my numbers, my original numbers, -2 and so on, the same numbers. The minimum I can see is -2. The maximum is 5. And that's what I got here. Minimum is 2, maximum is 5. And therefore the range is maximum minus minimum. So 5 minus 2, 5 minus -2, which is 7. Now I need to compute IQR. To compute IQR, I need to have my numbers Q1 and Q3. So I'm copying it from the previous computation. And I've got Q1 equal to -2 and Q3 equal to 1. And therefore IQR is Q3 minus Q1, Q3 minus Q1, which is equal to Q3 is 1, minus Q1 is -2, and therefore I get IQR as to be 3. So these are what are called my measures of dispersion. The top thing which I have here also has a label to it, and that is called the 5-number summary. The 5-number summary has 5 numbers. The first one is the minimum, the least number in the data set. The second one is the first quartile. The third number is the second quartile, which is the 50th percentile, which is the median. Then you have Q3, which is the 75th percentile. And finally, the maximum number. And this is called the 5-number summary, which we are going to use in the next slide to develop something called a box plot. Now we are going to develop what is called a box plot. This is a visual way of representing the data. And a box plot also helps us to identify what are outliers, which for this exercise, I do not have any outliers. But the next slide, we will be looking at the Kentucky Derby completion times, and there we will find outliers. So how do I develop a box plot? So first I start off with the 5-number summary, which I copied from the previous slide. The minimum, Q1, Q2, Q3, and the maximum, which are given out here. From this 5-number summary, I will first compute the IQR, the interquartile range, which if you remember is 1, Q1, 1 minus 2, which is Q1. So Q3 minus Q1. So 1 minus 2, which is 3. I then compute something called 1.5 multiplied by IQR, which is 3 multiplied by 1.5, which is 4.5. And then I compute two things. One is called the upper limit and one is called the lower limit. The upper limit is Q3, which is 1, plus this number 4.5. So 1 plus 4.5 is 5.5. And I also compute the lower limit, where I look at Q1 and then subtract that number 4.5 from that. So minus 2 minus 4.5, which is minus 6.5. So unfortunately for this data set, you can see that none of these 6 numbers is greater than the upper limit, and none of these 6 numbers is less than the lower limit. And therefore for this problem, for this example, I do not have outliers. Now how do I draw a box plot? The first thing I do is, if I'm doing it by hand, this picture I did it through, I got Excel to generate this box plot from me. But if I do it by hand, I first draw these fences, the lower fence and the upper fence. And where are they? If I look at this as the value, this is going to be minus 6.5 and this is going to be 5.5. And then what I do is I identify the location of Q1, Q2 and Q3. So this box, I draw this box, this box out here. The lower part of the box is Q1 and Q1 is minus 2. So this must be minus 2. The upper part of the box will be Q3 and Q3 is 1. So this is 1. Inside this box, we'll also display the median, Q2. So this point out here is Q2 and this must be minus 0.5. And now we need to extend from this box upwards and downwards. We need to draw a line. Now how far does this line go? This line will go to the maximum value, which is less than the upper fence. For this data set, all numbers are below the upper fence and the maximum value is 5, and therefore this number out here is going to be mapped at 5. For this data set, we see that the minimum is -2, which is coinciding with Q1, which is also -2. And therefore, there's no line protruding downwards from the lower end. And therefore, this is going to be my box plot. All right. Let's take the Kentucky Derby instead. Thank you.